Hello everyone. Today we're going to be going over one of the problems in our study guide. So this problem says use the figure above and the fact that the line L is parallel to the segment AC and prove that the sum of the angle measures in a triangle is 180. So we have our columns for statements and our columns for reasons. What can we do with that? Well, we all know, hopefully, what the first reason always is. It's always given. So I can just go right here and write given. Okay. Now what is given to me? The fact that L is parallel to AC. So the line L is parallel to AC. And what are we trying to prove? Because whatever we're trying to prove is going to be the last line. We're trying to prove that the angle measures in a triangle is 180. Angles in a triangle, and I'm just going to abbreviate, equals 180. So, what can I do to prove that? Well, if we look at the angle measures in our triangle, it's angle 4, angle 2, and angle 5. So if I can show that the measure of angle 2 plus the measure of angle 4 plus the measure of angle 5 equals 180, then that proves what I'm trying to prove. So let's go to there. So all we have to start with is that L is parallel to AC. What can we do from there? Well, the line L is the one up here, line L, and AC is down here. They're two parallel lines. And we have two transversals, AB and BC. And because of that, we can figure out a few things about our problem. So let's look at some of the things we have. We have angle 1 up here. Well, with all those properties of parallel lines, I know that angle 1 and angle 4 are congruent. They are congruent because they're both on the interior of the parallel lines and they're on alternating sides of the transversal. So they're alternate interior angles. So I know that the measure of angle 1 equals the measure of angle 4, and that's alternate interior. Similarly, I can look at angle 3 and angle 5. They would also be considered alternate interior angles. They're on the interior of the parallel lines and they're on alternate sides of the transversal BC. So the measure of angle 3 is equal to the measure of angle 5. Same reason. Well, what else do I know? If you look, 1, 2, and 3 are all angles on a straight line. So I know that the angle measure of a straight line is 180. So I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. And that's just because of angles on a straight line. Angles on a straight line equal 180. And perhaps you can see where I'm going to go here. We know angle 1 is equal to the measure of angle 4. So I'm going to replace angle 1 with the measure of angle 4. Keep everything else the same. And how do I know that? Because of substitution. All I did was substitute angle 1 with angle 4 in our equation. So the reason is substitution. Similarly, I know angle 3 and angle 5 are the same because we proved that earlier. So I'm going to substitute angle 3 with angle 5. And same reason, substitution. Well, what do you know? This line here is the same thing as the line we had down here to show that the angles in a triangle are 180. So we didn't even need this extra space. I'm just going to draw an arrow to go down here. And then to get from this line to this line, it's just definition of interior angles. So now we have shown that adding up angles 2, this angle here, 2, 4, and 5 equal 180, which is the sum of the measures in a triangle. So that proves what we were trying to prove.